Take a look at this archival photograph of the pyramids of Giza. Thousands of years before the modern mathematical formula was written down, ancient builders were already using precise ratios to ensure their monuments stood perfectly straight. Egyptian rope stretchers used a highly specific technique. They took a rope with evenly spaced knots and physically stretched it into a triangle with sides of 3, 4, and 5 units. Doing this guaranteed a perfect right angle for their construction corners. Today, we are going to break down exactly why that works by mastering the Pythagorean theorem. We have clear goals: identifying triangle parts, understanding the core formula, and applying this math to real-world problems. Named after the Greek philosopher Pythagoras, this theorem is the bedrock of geometry. It establishes a perfect relationship between the lengths of the sides in any right-angled triangle. Let's start with the anatomy. A right triangle always contains one 90-degree angle, marked here by the small square. The longest side, which sits directly opposite that right angle, is called the hypotenuse, labeled C. The other two sides are the legs, labeled A and B. Here is the core formula: a squared plus b squared equals c squared. Remember, this equation only works for right triangles. Look at this geometric visual. If you build physical squares perfectly matched to the lengths of leg A and leg B, the total area of those two smaller squares combined will precisely match the area of the square built on the hypotenuse. Now let's put that formula to work. If we have legs of 6 and 8, we square them to get 36 and 64. Adding those gives us 100. The square root is 10, making our hypotenuse exactly 10. If you know the hypotenuse is 10 and one leg is 7, you solve for the missing leg by subtracting 49 from 100, leaving 51, D1. This math translates directly into consumer technology. A smartphone screen is measured diagonally. If it is 6 centimeters wide and 8 tall, it is accurately labeled as a 10-centimeter display. It applies to safety, too. If a wall is 12 meters high and a ladder rests 5 meters from the base, the ladder must be exactly 13 meters long. Avoid 3 frequent mistakes. First, never treat a leg as the hypotenuse. C must be the longest side. Second, square the numbers before adding them. Third, remember that physical distance is always positive. Now it is your turn. The legs are 5 and 12. 5 squared is 25, and 12 squared is 144. Add them to get 169. The square root gives us a final hypotenuse of 13. You can solve any right triangle problem by following these 4 steps. Confirm the right angle, identify the sides, plug them into the formula, and execute the math. If you label your sides accurately from the beginning, the formula will guide you to the correct answer every time.